And good morning, fourth grade students. Welcome to another edition of Mr. Leggett's Eureka Math. And as you know by now, Eureka is a Latin phrase. When translated into English, it means I have found it. And what have we found? Well, we have found, scholars, the best way to learn math. And that's more valuable than gold itself. So today we're working on Module 5, Lesson 4. Let's take a look at our objective, what we're out to learn today. And that is decompose fractions into sums of smaller unit fractions using tape diagrams. So more of that. So we're going to decompose fractions, smaller unit fractions, and we'll use tape diagrams. A lot going on. Let's find out what happens. Our fluency practice, we're going to break apart fractions. At least I think that's what we're going to do. Yes, we are. So, follow along with me. Go ahead and write this, draw this tape diagram. Okay, we're going to start with that. Tape diagrams, we're very familiar with them by now. Excuse me. Got to get my timer going. All right, now we got our tape diagram. Let's go and break it into thirds. So 1/3, 2/3, 3/3. And this is 1, of course. So we can take a look at this tape diagram, and we could say that it represents, if we shade in 2, we could say that 2/3 equals 1/3 times, plus 1/3. So 1/3 plus 1/3. 1/3 plus 1/3 equals 2/3, right? We can use this in multiplication though, can't we, like we did yesterday? So blank times 1/3 equals 2/3. What number would go there? Well, if we remember from yesterday, 1/3 and 1/3, so it'd be 2 times. 2 times 1/3 equals 2/3. Let's take a look at another one. Got a little room over here. Excuse me. And let's do 3/5. So it's fifths, so I'm going to go 1, 2, 3, 4, and 5, and I'm doing 3/5. Remember yesterday when we were complaining, we were saying, oh no, don't have to write this out like this, but yes we do, to show that it's multiplication. We're going to say, there we go, we're going to say that 3/5 equals 1/5 plus 1/5 plus 1/5. Of course that equals 3/5. 1, 2, 3, and the denominator doesn't change. The numerator's 3 now, 3/5. How would we do this multiplication wise? Blank times 1/5 equals 3/5. What would that be? Well, of course, it would be 3. 3 times 1/5 equals 3/5. 1, 2, 3. And there we have it. And let's squeeze some room for a little one more over here. Let's do one that's greater than 1. We're going to do 5/4. So I'm going to go 1, 2, 3, 4, and 5, right? And they're fourths, so my 1 consists of 4/4, right? But it's 5/4, so I'm going to color in all, or shade in all 5. So we have 5/4. And what does that equal? Well, it would equal 1/4 plus 1/4 plus 1/4 plus 1/4 plus 1/4, right? 1, 2, 3, 4, 5, 5/4. Let's do multiplication. Blank times 1/4 equals 5/4. What do we have? Of course, I hope you said 5. 5 times 1/4 equals 5/4. Okay, we're going to move on. Excuse me. Got wind yesterday, got my allergies going. All right, let's start with our application problem. Let's find out what we know. A recipe calls for 3/4 cup of milk. I'm going to circle 3/4. That's what we know. Sasha only has a 1/4 cup measuring cup. So only 1/4 cup. She has one of those little things you've seen your parents use maybe when they're cooking. If she doubles the recipe, you circle the word doubles, times 2. What we need to find out is how many times will she need to fill the 1/4 cup with milk. We need to draw a tape diagram and record as a multiplication sentence. So look at all that that's going on. So let's find out how Sasha does this. Okay, so let's think about this. It calls for 3/4 cup of milk, right? But we need to double that, all right? So let's go ahead and get to that. So it's 3/4. What's 3 times 2? 6. So let's make a tape diagram. And just so that you see this, 1/4, 2/4, 3/4. But we need to double that. 4/4, 5 and 6/4. So there we have it. Now where will our 1 be? Well, it's fourths, so we need to go 1, 2, 3, 4. And that's our 1. Okay, now she only has the cup that measures 1/4 each time. She needs to take a trip to the store and get some more measuring cups, I think. So we have 1/4 there. So how are we going to figure out how much she needs to fill this 1/4 cup? Well, let's take a look at that. We doubled it. 1/4, 1, 2, 3, 4, 5, 6. So let's do 6 because we need to write a multiplication sentence. 6 times 1/4 equals what? What fraction would that equal? Well, if you said 6/4, you're absolutely correct. So how many times will she need to fill that little cup? Let's write that down. Because we read, we drew, and now we write. Sasha needs to fill the cup 6 times. There we have it. Let's move right along to our concept development. This is something brand new. Moving at the speed of light here, it seems like. Our problem 1 says use tape diagrams to represent the decomposition of 1/4. Shall I get that right? Nope. Cross out 1/4, class. 1/3 as the sum of unit fractions, okay? So let's start off with 1/3. Let's make a tape diagram that shows 1/3, okay? And this time I want you to be really super duper careful. I know Mr. Lake sometimes goes super fast, but we're going to be really careful how we do this, okay? So let's make thirds. 1, 2, and 3, okay? So we're going to show 1/3, all right? Listen carefully. This is brand new stuff here. One third. Okay? So we have 1/3. Now, I'm going to take a light colored Sharpie to shade. And I'd like you to shade it lightly, not dark, but just shade it lightly, okay? And usually I just, kind of shade in really quickly. I'm going to shade in the whole thing. So now your model should look like this. All right? What we're going to do now, excuse me, where'd my purple pencil go? Huh. Purple, oh, there's purple. We're going to show that 2/6 is the same as 1/3. And you might say to yourself, how can be? Well, I'm going to show you. We're going to just go like this. We're going to break this into 6. There's 1, 2, 3, 4, and 5/6. So each one of these now are 1/6. 1/6. And 1/6. So we could see that 2/6 do in fact equal 1/3. 1/3, and we just split them in half and they became 2/6. I know it's a kind of something new to wrap your heads around, but it is true. So let's see what else we can do with this. How I can show this to you. We'll say 1/3, right, equals 1/6 plus 1/6. We can see it right there. There was 1/3 in yellow. Then we split these in half. They became 6. So we see that 2/6 does in fact equal 1/3. Then we can say that 1/6 plus 1/6, we've been doing this addition for a while, equals 2/6. They're all equal. 1/3 equals 1/6 plus 1/6 equals 2/6. We can see that 2/6 is equal to 1/3. How else can we do this? Well, let's find some other ways we can do it. We can say that 1/3 equals 2 times 1/6, which equals 2/6. All equal, right? Let's go over here and do a number bond, or a fraction bond. We have 1/3, and they equal what? 1/6 and 1/6. Added together, they equal 1/3. We're going to do a few more examples so you really get the hang of this, I hope. I know you will. We're going to take this right here, and let's have a little more fun with this fraction. Can you believe it? I can. Let's say, no, let's make a new one. We'll do a new fraction down here. Got a little room. Are you ready? Can you dig it? I hope so. We're going to make another thirds. 1/3, 2/3, and 3/3. I'm going to show 1/3. Okay, we got that? Now, are you ready for this? We're going to shade in with, really carefully, you shade in with your pencil lightly. I'm going to shade in with my yellow Sharpie. So there we have that. You can do the same thing like we did before. And we're gonna chop it all in half into sixths, just like we did before. Okay, we got this going on. Now, let's go ahead and label this. One sixth and 1/6. I could use brackets, but I just don't have the room. But what if we were to go really wacko and say, you know what? Let's divide these suckers again. Can we do it? Can we do it? Yes, we can. We can further decompose the fractions. Let's do it. So I know that 1/6 plus 1/6 equals 1/3. What if I was to divide them again? Excuse me. So I divided them all in half again. How many do we have now? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm seeing something here. Then we have, we'll make a little brackets, little tiny brackets. And we can see that this is 1/12 plus 1/12 plus 1/12 plus 1/12 equals 1/3. So 4/12 equal 1/3 and 2/6 equal 1/3. Isn't that remarkable? I think it is. Let's go to our next page. Yours is on the back side. This is Mr. Leggett uses Sharpies. I do them like this. That's how I do them. Isn't that fascinating? All right, let's find out what's going on with this problem. It says use tape diagrams to represent the decomposition of 1/5 and 2/5 as the sum of smaller unit fractions. A lot going on there, but I think we can do it. So, first of all, let's make a tape diagram showing 1/5. All my pencils are slowly losing their ink, our Sharpies. So let's make 1/5. 1/5, 2/5, 3/5, 4, and 5/5, okay? So we're gonna label this section 1/5, okay? So what if I were to do this? What if, and in fact, I'm gonna do this. I'm gonna have my yellow. I'm gonna shade in 1/5. You can do the same lightly with your pencil because we're gonna split this up and decompose 1/5. And I will say, here we go. Let's do 1 time. We're gonna break it up into like this, 1, 2, 3. So now what do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We now have 15ths, okay? So let's see what happens here. Make some little tiny brackets. Little tiny brackets. And there's 1/15 plus 1/15 plus 1/15. So 1/15 plus 1/15 plus 1/15 must be equivalent to 1/5. We can see that right there. It's just that we've broken this up into more parts. All right? So let's see how this looks using a math sentence. So we could say 1/5 equals 1/15 plus 1/15 plus 1/15. Okay? What does that equal? It equals 3/15, right? So now we could say that 1/5 equals 3 times 1/15, right? 3 times 1/15 equals 1/5. We could further state in our number bond, our display, not state really, 1/5 equals 1/15 times 3. Okay, there we got it. Let's take a look now at 2/5. So we're not going to do the whole tape diagram thing. We're going to say 2/5 equals, it would equal what? Well, think about it. We know that 1/5 was 3/15, right? So 2/5 must equal 3/15 plus 3/15. And that would equal 6/15. We can also say that 2/5 equals 3 times 1/15, right? Plus 3 times 1/15. Okay? So let's just show the 2/5 here, why it equals 6/15. Just take a look. 1, 2, 3, 4, 5, and 6. So if we had 2/5, 2 out of 5, but we broke them up into 3 segments here to 15ths, it would be 6/15. So 2/15 does in fact equal 6/15. Woo! Keep it moving. Okay, problem 3, draw a tape diagram and use addition to show that 2/6 is the sum of 4/12. Okay? So we're going to start with a tape diagram. And let's break this up into sixths, okay? 1, 2, 3, 4, 5, and 6. Okay, how many sixths do we have? We have 2/6, okay? So what I'm going to do is use my trusty yellow pen. 1, there's 2/6. I'm representing 2/6. What if I were to break this up into twelfths? Let's do it. So if I break this up into twelfths, I have 6 right here, so I'd have to go 2, 4, 6, 8, 10, and 12. So there's my 2/6, and I've broken it up into twelfths. We have 2/6, and we've broken them up into twelfths. So let's see what's going on here. So 2/6, now they become twelfths, right? Because we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I'm making my tiny little brackets. There's 1/12 plus 1/12 plus 1/12 plus 1/12. It looks like it's going to equal 4/12 to me, but let's double check everything here. We'll use a number bond. And we'll say 2/6 does in fact equal 4/12. Oops, excuse me, that's just 1/12. So he got ahead of himself. 1/12, 1/12, and 1/12. So we have 4/12 does in fact equal 2/6. We can see it right there. Let's use some math sentences to represent this. That 4/12 equals 2/6 are the same. So we'll say that 2/6 equals 1/12 plus 1/12 plus 1/12 plus 1/12, right? 4/12. They equal, and that would equal 4/12. They are all equal. Voila! Look at it another way. 2/6 equals 2 times 1/12, right? That'd be 2/12 plus 2 times 1/12, which equals 4/12. We're proving this is equal over and over again. Then we can say that 2/6 equals 4 times 1/12, which equals what? 4 times 1/12, 1, 2, 3, 4, 4/12, and it is all equivalent. Okay, take this time to take a little stretch break and pause the video, because when you come back, we got a problem set to do. Yay for the problem set. Problem set time. Time to deal with the problem set. The set of problems. Alrighty, it's problem set time. Hope you had a nice little stretch. Got ready to work with the problem set. We're on page 123. And today's date is 02. What is today's date? Huh. 03, 2020. All right, let's look at our instructions first. I'll zoom in a little bit so you can see a little easier. Oh, wrong way. Wrong way, Mr. Leggett. Okay, here we go. Hi. So, the total length of each tape diagram represents 1. So all these represent 1. Decompose the shaded unit fractions as the sum of smaller unit fractions in at least 2 different ways. The first one, thank goodness, has been done for us. So what we did on the first one right here, I'm going to zoom out a little bit, it's a little too tight. There we go. First one here, they took 1/2 and they decomposed it to 1/4, 1/4. Then they took 1/2 and they decomposed it to 1/8 plus 1/8 plus 1/8 plus 1/8. They're all equivalent, okay? So let's see what we can do, okay? We have 1/3 right here, right? What was it decomposed into? 1, 2, 3, 4, 5, 6. Our denominator is going to be 6, right? 1, 1, right? Add them, and we get 2, 6. But we need to come over here and put our original fraction of 1/3 equals. All right, let's decompose it further. Smaller and smaller. So we still have 1/3 here, but we partitioned it into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I'm going to put 1/3 equals, we have 1/12, 2/12, 3/12, 4/12. So it'd be 1/12 plus 1/12 plus 1/12 plus 1/12. What is 1 plus 1 plus 1 plus 1? Why, that equals 4/12. What? Let's go on down here. Now they're not labeling it for us. We got to figure this out, but we're all very smart. So we can look at this one. We have 1, 2, 3, 4 pieces. So I know it's going to be a fourth, and one is shaded. Let's go ahead and decompose this. I'm going to make some dotted lines here. Just splitting them right in half. Okay. So now what do we have here? Make our little tiny little brackets. So we'd have 1 out of 1, 2, 3, 4, 5, 6, 7, 8. We'd have 1/8. So I can say 1/4 equals 1/8 plus 1/8. Which equals 2/8. Okay. Now we're going to break them into 3 different parts. Okay. 1, 2, and 3. 1, 2, and 3. 1, 2, and 3. 1, 2, and 3. So now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pieces, right? 12. So my denominator is going to be 12. We're still showing that this is 1/4, right? So 1/4 equals how many 12s? 1, 2, 3 equals 1/12 plus 1/12 plus 1/12, which would equal 1, 2, 3 out of 12. 3 12s. Let's head on down here, and we see I have 1 shaded and 1, 2, 3, 4, 5. So it looks like it's 1/5. All right, I'm going to put my 1/5 here, and my 1/5 here equals, and my 1/5 over here equals. So let's split these in half. Okay, we split them in half. Let's count how many there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How about that? So this is going to be a 10th. Oops. Got to do my little brackets. Got to love those little tiny brackets. Did you say little tiny brackets? Oh, Princess Yvonne, yes I did. Little tiny brackets. Oh, I love the little tiny brackets. Well, I know you do. You've often told me that before, that you love the little tiny brackets. Yes, they're so adorable. Yeah, and they come in handy when we're doing fractions too, don't they? Yes, they do. Take a look right over here. We see the little tiny brackets show us that 1/5 could be 1/10 plus a 1/10. Isn't that right, Mr. Leggett? Yes, it is, Princess Yvonne. I'm so happy that you decided to drop by and visit today. Oh, so am I. I love to see the little tiny brackets. Okay, have a good day, Princess Yvonne. You too, Mr. Leggett. Well, it's such a pleasure when she comes by and visit. So we have 1/10 plus 1/10. What would that equal? It would equal 2/10. And there we have it. Let's break them now into 3 different parts. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. And instead of counting, I can just go, 3, right, times 5 would be 15. I've got my 1/5 up here. So now they're 15ths. How many 15ths? 1, 2, 3. So 1/5 would equal 1/15 plus 1/15 plus 1/15 equals 3/15. There you have that. So we'll continue on with the back side. The total length of each tape diagram represents 1. Decompose the shaded fractions as the sum of smaller unit fractions in at least 2 different ways. So we're doing pretty much the same thing. Here's 2/3, right? So I'm going to put 2/3, and let's break this up. I'll put 2/3 here, and we have 2/3 over here, equals, and 2/3. So let's set up our problem like that. Now, what does 2/3 equal if I decompose it? 1, split these in half. What do they become? 1, 2, 3, 4, 5, 6. They become 6th. So we have a 6th plus a 6 will equal something. How many 6s do we have? 1, 2, 3, 4. Oh, we have 4 6s. I need to keep going. Plus a 6 plus a 6. So we have 1 6 plus 1 6 plus 1 6 plus 1 6. I ran out of room. It equals 4 6. So 4 6 is equivalent to 2/3. Now, let's chop this up into 3 pieces. 1, 2, and 3. 1, 2, and 3. 1, 2, and 3. How many do we have now? 1, 2, 3, 4, 5, 6, 7, 8, 9. We became ninths. Okay, how many ninths? 1, 2, 3, 4, 5, 6. So 1/9 plus 1/9 plus 1/9 plus 1/9 plus 1/9, 1, 2, 3, 4, 5, plus 1/9 equals 1, 2, 3, 4, 5, 6 ninths. And we can see that. 1, 2, 3, 4, 5, 6, 6 ninths. I hope we can see that. Yeah, we can see that. Okay, let's continue on with B. What do we have here? 1, 2, 3, 4, 5. So my denominator is 5. And we have 1, 2, 3 fifths. What is this going to equal if I divide these in half? So we put all our 3 fifths over there. Let's go ahead and do it. Just splitting them in 2. 1, 2, 3, 4, 5, 6. Okay, so it became, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They became tenths. How many tenths? 1, 2, 3, 4, 5, 6. So 1/10 plus 1/10 plus 1/10 plus 1/10 plus 1/10 plus 1/10. I'm out of room. 1, 2, 3, 4, 5, 6 equals 6/10. Okay, our next one, it's still 3 fifths, right? Well, let's go ahead and divide them into 3 sections. 1, 2, and 3. 1, 2, and 3. 1, 2, and 3. 1, 2, and 3, and 1, 2, and 3. So instead of going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so on and so on, I can just do 3 times 5. What's 3 times 5? 5, 10, 15. So how many 15ths will equal 3 fifths? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1/15 plus 1/15 plus 1/15 plus 1/15 plus 1/15. That's 1, 2, 3, 4, 5 plus 1/15. There's 6 plus 1/15, 7 plus 1/15, 8 plus 1/15 equals 9/15. So 9/15, 6/10, and 3 fifths are all the same. They're all equivalent. We're not going to do this part. Please put this away to help you out with your homework tonight. And thank you so much for tuning in to another exciting edition of Mr. Leggett's Eureka Math. Ooh.